Hello everyone and welcome to Math with Miss Murthy. This is our first lesson of the year. This year we are starting off our units with unit 3. Okay, so this unit is a unit where we work with multi-digit whole numbers and fractions. We're going to be practicing our different mathematical operations for whole numbers and fractions. Now the way this my videos will work is I will be working on your book. These slides that I'm using are the exact same as your book, and we'll be working through these problems. Every so often I'll ask you to pause and do the think about it, talk about it sections, also to do the pause and check problems on your own, and then I'll share the solutions. Okay, so as you watch this video, I want you to have your math textbooks right in front of you and work along with me. Also, at the beginning of each lesson, I will show you a warm-up which I want you to pause, solve on your own, and then I'll share the solutions. And I will also share the standards for mathematical content and standards for mathematical practice. I would like you to pause and check these on your own. In the interest of the length of the video, I'll keep this short and I'll keep scrolling through those. All right, so today's lesson goal is to find quotients of multi-digit whole numbers. Okay, so when one number is divided by another, the result is called the quotient. The dividend is the number that is divided, that gets divided. The divisor is the number that we use to divide the dividend. So in our expression where we have 240 divided by 80, which gives us an answer of 3, the answer 3 is our quotient. The number 240, which is the number that gets divided, that is our dividend. And the number 80, which is the number that divides 240 into 3 parts, is our divisor. Okay. Let's take a quick look at example 1. Dividing multi-digit numbers, we are finding 2570 divided by 12. Now sometimes my slides might be a little messed up. It's missing the divide by sign over here. So we're finding 25,740 divided by 12. So if you look at this, what we're going to do is we're going to divide the numbers in each place value position starting from the left. So if we first look at 2, right? I'm just going to block out everything else. 2 cannot be divided by 12, which is why we're dividing 25 by 12. That gives us 24. 2 and 12 times 2 is 24, so we can write that down here. So 25 minus 24 gives me a 1. I bring down the 7. Then I divide 17, gets divided once, so 12, that gives me a remainder of 5. And then I bring down my 4, and then my 0. Finally, I have a remainder of 0, but my quotient, 25,740 when divided by 12, gives me a quotient of 2,145. Okay, now I want you to pause right here and think about this on your own. How can you check to see if the quotient is correct? Well, the easiest answer is we multiply the quotient by the divisor, and if there is no remainder, then the product should be the same as the dividend that we had. All right, I want you to pause and do this check problem on your own. 52,428 divided by 34. I'll share the solution with you in a moment. The solution is 1,542. Now, what do we do if two numbers do not divide evenly? What we can do is we can write the quotient as a whole number with a remainder. For example, in this same question, if we had 52,000, let's say 429 divided by 34. Now we know 52,428 divided by 34 is this much. If I were to divide 52,429 divided by 34. What I would have is a quotient of 1,542, and I have a remainder of 1. So if two numbers do not divide evenly, we can write the quotient as a whole number with a remainder, or we could continue dividing by adding a decimal point to the right of the whole number, and then we annex zeros to help us continue our long division. Okay, we can annex as many zeros as necessary to the right of the number in a decimal number. Okay, as long as we have the decimal point. And we're going to take a look at that example now, where we are comparing long division using remainders and long division by annexing zeros. So if you look at the question on the left, both of these questions in fact are 820 divided by 25. So on the left, we're doing it with remainder. That gives me a quotient of 32 and a remainder of 20. Now, if I were to instead continue dividing, I added a decimal point, and then I annexed a 0 to the right of the decimal point. That gives me, instead of 20, I have 200 over here, right? And 200 gets divided by 25 8 times. All right. Now, we know that a remainder can be written as a fraction in the numerator and a divisor in the denominator. So, to check that 32 remainder 20 is equal to 32.8, we first write the remainder as a fraction, right? So, our fraction here would be 20 divided by, what was our original divisor? 25. 20 divided by 25 is the same as 80 divided by 100, which is nothing but 0.8. So 32 remainder 20 can be written as 32 plus 20 by 25, or that would be 32 plus 0.8. All right, I want you to pause this right here and take a moment to think about it, respond to the question in the Edpuzzle. How do you know that 820 and 820.0 are equivalent? We know that they're equivalent because adding zeros to the end of a decimal after the decimal point does not change the value of the decimal. All right, let's move on. Let's take a look at example 2. 5,272 divided by 64. Okay. Now again, we're going to write. First of all, before we start this, how are you going to set up your division? Think about it, and we'll talk about this in the class. Okay. Now, when we set up our division, 5,272 divided by 64, we're going to divide from left to right. We know that if I only had 52, that could not get divided, so I need to consider 527. 64 goes 8 times. Okay, now how do we know 64 goes 8 times? Well, we could start off with the approximation. 64 times 5 we can deduce is 320, and this is definitely a lot more than 320. It's 207 more than 320. And that would put us at approximately 3 times more. So I can conclude that's 8 times. We multiply 8 times 64, subtract that, get the difference, then carry down the 2. Same way. At this point, we've now added a decimal. 0.0, we can annex as many zeros as needed. We carry those down until we get a remainder of 0. Okay. So we know 5,272 divided by 64 is 82.375. Now, in this case, how do you know when you're done dividing? Take a moment, think about it. Well, we know we're done dividing when when the remainder is 0. So that means no further division needs to take place. All right, moving on. We're gonna I want you to pause this right here, do this check problem on your own. 16, and this is on page 137 of your textbook. Okay, this is on page 137. Find 16,047 divided by 60. I'll share the solution with you in a moment. There you go. The solution is 267.45. All right, let's look at example 3. We have 5,272 divided by 340. Okay. Now again, let's see. Okay. Again, we're going to divide from left to right and we're going to annex zeros as needed. Okay. So in this case, 528, 340 goes once in that. So I subtract 340, I get 188. I carry down the 7. After that, I start my decimals. Okay, I can carry down this 0 and this 0, which gives us an answer of a quotient of 15.55. Alright, I want you to pause the video right here. Do this check problem on your own. 462 divided by 250. The answer is 18.48. Now, let's take a look at the supply problem. Okay. The table shows the number of cookies donated for each school bake sale. The cookies were placed into bags with 1 dozen cookies in each bag. How many such bags of 1 dozen cookies were available to sell? Okay. Let's take a moment, right? We know for each type of cookie, we are going to put them into 1 dozen cookies in each bag. So we are going to but before we get to it, sorry, I want you to pause right here. Think about why is the final answer? Why do you think the final answer might be given as a whole number when we might possibly get our quotient as a decimal? Okay. I need to add on a page right here to work through this problem with you. Sorry, bear with me. All right. So to find out how many bags of chocolate chip cookies we can make, what we are going to do is we are going to divide 125 by 12 cookies because that's how many can go in each bag, right? So I have 1 right here, 12, I subtract 0, I carry down the 5. In 5, this will go 0 times. So I can add a decimal and annex a 0. I can pull that down right here. And I'll also add the decimal in my quotient. So in 50, 12 goes 4 times. That gives me 48. So I'm left with 2. I can annex another 0. In 20, I get it once. That would put it at 12. 8. It's going to go 6 times. That gives me 72. Now I know that I'm going to keep repeating the 8s every time. Okay. So I get 10.416. Now can I make 10.416 bags? No, I can't. So therefore, and I'm going to add a table column to this table right here. I can only sell 10 bags because my 11th bag will not have sufficient. That's why in this case I'm rounding down. Okay. Now next let's look at the oatmeal biscuits. I know 60 divided by 12 is 5. So I could just say 5 bags right here. Okay. Next up, I'm going to look at peanut butter cookies. 245 divided by 12. In 24, I get 2. I can add a decimal, annex a 0. In 50, I would get 4 times. 48, that's 2. 20, I get 1. And then we know at this point, it's going to be repeating. Again, I can only list 20 whole bags because the other one is not going to be a whole bag. Then my last is sugar cookies, 116 divided by 12, that's 0. In 116, 12 goes, let's see, 9 times. That would give me 108. I can add annex a 0 as long as I add that decimal here too. So once I get 80, I know it can go 6 times, 72. And this is going to keep repeating. 9.6666. But how many full bags can I have? 9. So how many bags of 1 dozen cookies were available to sell? What you could do is you add all of these up. That's 39 and 5, 44. Another way to do them would be to add all of the bags up and then divide that by 12. Alright, here I've kind of already addressed this. Why is the final answer given as a whole number when the quotient is a decimal? Well, this is because you cannot sell a half bag or a quarter bag of the cookies. It has to be a whole bag quantity. Alright, we are coming to the end of our chapter. So I want you to pause and do this check problem on your own. And this check problem is on page, let's see, page 140 of your textbook, okay? And we'll be asking you to enter the solution to this either in the Edpuzzle or a Google form, okay? I also want you to pause and reflect. When dividing whole numbers, the quotient can be written with a remainder, or you can annex zeros and continue dividing. So how do you think these two methods are similar and how are they different? Okay, think about it and we'll talk in class tomorrow. Bye-bye.